It takes an astronomical amount of work and engineering capabilities to carve a tunnel beneath the sea. For most countries, that's a dream too wild to be attempted. But in China, it's already happening. And this project isn't just a tunnel, it's a symbol of how far a nation is willing to push the limits of human engineering. In this video, we are exploring China's Jintang Undersea Tunnel, the world's longest high-speed rail tunnel under construction. Located in Zhejiang province, the Jintang Undersea Tunnel is designed to connect the booming port city of Ningbo with the Zhoushan Islands, an area that until recently was isolated by the sea. The tunnel itself will stretch 16.18 kilometers, with 11.21 kilometers dug directly under the seabed using colossal tunnel boring machines known as shields. To put this into perspective, that's about the same distance as walking from Manhattan to Brooklyn and back again, all beneath the ocean floor. The tunnel will also run 78 meters below sea level, putting it under pressure levels that would crush submarines from older generations. And yet, inside this tunnel, trains will race at 250 kilometers per hour, carrying passengers across in under 30 minutes. This tunnel isn't just shaving off minutes, it's rewriting how entire regions connect. And when compared to the inconvenient and time-consuming travel between Ningbo and Zhoushan, you will realize that this innovation is light years ahead of many train infrastructures in recent years. Building any tunnel is risky. Building one under the sea, that's a whole new level of danger. Let's look at how China overcame the engineering problems that made the mega project almost impossible to construct. Apparently, the Jintang Undersea Tunnel faces 28 geological transitions along its route. That means the tunnel boring machines aren't just cutting through uniform rock. They're constantly switching between soft soil, sticky clay, loose sand, and solid granite. Each of these behaves differently under pressure. Soft soil collapses easily, while rock can shatter unpredictably. To handle this, China is deploying two custom-built shield machines, Dingai and Yongzhou. These beasts are nearly 15 meters in diameter. They are large enough to fit a 5-story building inside. Their rotating cutter heads chew through earth with steel teeth, while pressure systems hold back the crushing weight of seawater above. But the most mind-blowing part is the precision. These machines, starting from opposite ends of the tunnel, must meet exactly in the middle. If they're off by even a few centimeters, the entire tunnel could be useless. To make these two machines function accurately, the construction procedure will follow a dual shield approach. Yongzhou will advance 4,940 meters from the Ningbo side, while Dingai will dig 6,270 meters from the Zhoushan side. The difference in their distance covered is due to the uneven geology of the construction site. As one of the machines digs the tunnel through a rocky strata on one side, the other one digs through softer soil on the other side, making symmetrical digging impossible. The final meeting point for both machines was deliberately chosen within a stable rock formation to guarantee a safe and accurate junction. The excavated materials, known as muck, are taken out via conveyor or muck cars, and lining segments consisting of precast concrete or reinforced concrete rings are installed immediately behind the shield to support the tunnel walls. Because this is under the seabed, additional steps are required to ensure safety. This includes sealing against water ingress using advanced lubrication, water injection, or grouting systems to ensure the durability and stability of the mega project. After excavation and lining, tracks and rail infrastructure are installed. Furthermore, the engineers will install drainage, electrical, and ventilation systems, as well as safety exits. They will also prioritize waterproofing and corrosion-resistant materials when executing the construction. Do you know? If engineers make even the tiniest error or one wrong calculation in an undersea tunnel, they could end up with two separate tunnels instead of one. To guarantee accuracy, engineers rely on Beidou satellite navigation, which is linked to the shield machine's auto-navigation systems. This system is China's answer to GPS, and its real-time corrections keep the two tunneling machines aligned within 2 centimeters. One more engineering problem to be overcome is the water pressure. At 78 meters deep, the tunnel is constantly under pressure equivalent to a building filled with water pressing down on every square meter. One leak, one failure, and the sea could rush in. Engineers have reinforced the cutter heads with special seals and added water injection systems to prevent clay from clogging the blades. They've even modified the drive systems so the machines can keep running without overheating over such a massive distance. According to available reports, the shield machines are to be dismantled in situ when the two ends meet. Their massive casing or shell body becomes part of the permanent tunnel lining. This process is known as shell shedding, and it allows parts of the tunneling machine shell to remain in place as reinforcement, rather than being entirely removed. Report has it that the estimated cost for the Jintang Undersea Tunnel project is $3.3 billion. Every mega project has a shadow, and for China's undersea tunnel, that shadow is long. First, the environment. Digging under the sea disturbs delicate marine ecosystems. Sediment clouds can choke fish populations, while vibrations affect breeding grounds for species that locals depend on. And once the tunnel is open, increased industrial activity in the region could accelerate pollution in the already stressed East China Sea. Then there's the human cost. Large infrastructure projects in China often involve land acquisition and relocation. Families are forced to move, sometimes with little compensation. Critics argue that these costs are brushed under the rug in the name of progress. And let's not forget the financial side. Mega projects of this scale consume billions of dollars in steel, concrete, and labor. Supporters argue the long-term benefits justify the spending. Skeptics point to abandoned or underused projects elsewhere in China as cautionary tales. Even safety is controversial. What happens if something goes wrong 78 meters below the seabed? Evacuating passengers in such conditions is nearly impossible. Engineers insist their safety systems are world-class, but the risk is always there, lurking in the background. While officials publicly describe the Jintang Tunnel as a regional link, some analysts believe it's actually a test run for something much bigger, a tunnel across the Taiwan Strait. Such a project, stretching more than 100 kilometers under the sea, would make Jintang look small by comparison. And while politically explosive, the engineering rehearsal is happening now. Whether or not that dream ever becomes reality, the Jintang Tunnel cements China's position as the global leader in infrastructure innovation. It shows not just technical strength, but a willingness to invest staggering sums into projects most countries wouldn't even attempt. Already, the shield machines have advanced some kilometers into the seabed. By 2026, the tunnel is expected to be fully dug through, and by 2028, high-speed trains should be racing beneath the East China Sea. What do you think? Is China rewriting the limits of human engineering, or is this a dangerous gamble with lives, money, and the environment? Drop your thoughts in the comments. I'd love to hear what side you're on. So hit that subscribe button, ring the notification bell, and join us as we keep exploring the world's boldest, wildest, and most controversial mega projects.